Today we are going to find the RMS and average value of this triangle which originates from the origin. There is a slope or rising slope from 0 to maximum voltage Vm for time period t. It is a continuous waveform for every time period t. From 0 to t there is one waveform, from t to 2t there is another waveform. So it is a continuous waveform. For this kind of waveform or a triangular waveform, if it is a triangular waveform, then also we try to find the slope of this triangle. If there is a triangle starting from 0 to pi by 2 or t by 2, we take a slope of this first half, which is a rising slope, and for the second half there is another slope, which is a falling slope. But here there is only one rising slope from 0 to t, so we take the slope of 0 to t, but from maximum voltage Vm to time, for time period t there is a instant fall, so we don't need to find the slope of the second half. Here is only a rising slope. So for a slope we know the formula, slope is equals to y-axis, the value of y-axis divided by the value of x-axis, y by x. The value of y-axis is maximum voltage Vm and the value of x-axis is 0 to t, that is written as t. So for this waveform we integrate slope in the time period t. Here to find the average value, we know the average value is given as 1 by total time period t. We integrate from the starting of the time period to ending of the time period, and ft dt. Here ft is equal to slope of the triangle in time t dt. So when we integrate that, Vm by t is a constant value, so we take it out from the integration. We don't need to integrate that, so that is a Vm. There is one t and another t, so it becomes t square. Integration from 0 to t, we integrate t in respect with dt. So the integration of t with respect to dt becomes t square by 2 from 0 to t. So here Vm by t is a constant value, so from maximum to minimum value we subtract. So maximum value is t, so we substitute this t square by this value t. So here it becomes t square, capital T square by 2 minus 0. After solution it becomes calculation, it becomes Vm by 2. So this is our average value in form of points. It becomes 0.5 Vm. So average value of a triangular waveform, a sawtooth waveform, becomes 0.5 of the maximum voltage. To find the VRMS value, we take the root of the voltage V square and we integrate from 0 to t. Again I forgot to write 0 to t there. So if we put the VRMS here, this is the whole time period t, integration from 0 to t. V square is the slope of the triangle, that is Vm square by t square in term of time period t. So t square, t also becomes t square dt. This 1 by 2 is in the form of root, so I write 1 by 2 in the power. When we integrate this t square, it becomes t cube by 3. From 0 to t is the integration time period, and 1 by 2 is the root over. When we substitute the value of t square for higher value of integration, that becomes t cube, the capital T cube. Here is another t cube, so we can cross the value of so the left value is Vm square by 3, which is in the form of root. Therefore if we take the root out, the value of VRMS is equals to Vm by 3, which becomes 0.557 of the peak value. So this is how we do the calculation for RMS and average value of the triangular waveform or a sawtooth waveform. Thank you.